All right, we're going to continue our journey into factoring and building our factoring skills by swapping out our single variable, right? So we had x. Well, what if I had something besides x? What if, not just an a or something, but what if I had a full expression or a function? So if I had a function like f of x, and then this is going to be a little bit new language, but if I said f of x equals 2x plus 1, this becomes my variable, okay? And then I would have 2x plus 1 squared, right? 2x plus 1 squared would be here. So let's start here. Factor completely. Well, I'm going to let, this is a simple factoring problem, if a squared is equal to x. So I know that x squared would then equal a squared squared, should be a to the 4. So you can see my substitution here is going to be x squared minus 5x minus 14. Okay? Now, you don't have to use the substitution. I'm using the substitution to explain how this works. So I replaced my a squared with x and my a to the 4 with x squared because they're equal. Okay? Get rid of some of those circles. Now I can factor x minus 7, x plus 2. Well, my original problem does not have an x, so I can't leave my answer like that. I have to reverse substitute or substitute my values back in. So I'm going to have a squared minus 7 and a squared plus 2. There it is. If I multiply this out again, I'm going to get my original trinomial. So the same thing here. Oh, now there's my x. I can't use x, so I'm going to say a is equal to x squared, and a squared is equal to x exponent 4. So I could say a squared plus 4a minus 5, then a plus 5, and a minus 1. And of course I've got to substitute back in. Except now, once I've substituted the x squared back in, I discover that I have a difference of squares here. So I'm going to say x squared plus 5, x plus 1, x minus 1. So this is what happens when we start factoring functions, or factoring where we have functions instead of variables. Sometimes some interesting results will result. Here, I'm just going to do this right away. I see that my variable-ish thing, my function, is x cubed, right? So I'm just going to rewrite this as f of x squared minus 9f of x, just to play with a little bit of this. 14, so I could say f of x, right? So if I say f of x is x cubed, right? And then what multiplies to get 14? Negative 7 and negative 2. And then I would say x cubed minus 7, x cubed minus 2. Okay? And if you want to just leave it as x cubed, you don't have to use f of x, or you don't have to use any substitution. Sometimes you can just go with it and it's fine. Okay, I'll do a couple more here. X squared, so that's what I'm using. So I have 4x to the 4 minus. Now here I have to use decomposition. So what multiplies to get negative 24, right? The 4 and the negative 6, and adds to get negative 5. And I see that I have negative 8 and plus 3, so minus 8x squared plus 3x squared minus 6. And then I'm going to use factoring by grouping, right? So I have x squared minus 2 and plus 3x squared minus 2, right? And it works. X squared minus 2 is common. 4x squared plus 3 is my result. Here I've got, two different variables. So that would be like my x. And then my x squared would be a squared b squared. So again, this is 198. What multiplies to get 198 and adds to get negative 31? So I'm going to have two negative values. So let's see if we can figure that out. What did that be? Minus... Well, for a problem like that, I could go to my calculator and just start dividing things. But if I look at the factors of 198, right, 198, I have 2 times 99, I have 9 times 11, and 3 and 3. So I could have something like 11 and 2 times, what's that, 9 times 2 is 18, right? So 11 times 18 gets me 198. What else? I could have 33 and 6. Well, that's right, and these would both be negatives, right? Negative 39, that doesn't help me. What about 22? Ooh, 22 and 9. Negative 22 and negative 9, that does get me negative 31. So for decomposition, maybe using the factors to get those numbers, if it's a number we're not used to, right? So we could say minus 22 AB and minus 9 AB. Plus 99. Also a hint too is look at this factor. It's going to be common with this one, something maybe, and then something common with 99. But anyway, it's all a journey. 2AB, AB minus 11, and then minus 9, AB minus 11. So we get AB minus 11 and 2AB minus 9. Great. Factor completely. This is a kind of a hint that we're probably going to have to do some follow-up factoring after the fact. So let's use factoring by decomposition again, no break. 8x to the 4, and that's a negative 24. So we're going to have plus 12x squared minus 2x squared. Remember, these two values have to equal this value. Minus 3, and then we'll factor by grouping. 4x squared, 2x squared plus 3, minus 1, 2x squared plus 3. Good. All right. So let's factor out the 2x squared plus 3 and 4x squared minus 1. And ta-da, that's a difference of squares, right? So we're going to say 2x squared plus 3 and 2x plus 1, 2x minus 1. So each of these steps is true. The one that's most simplified or most factored is this one, okay? So often students will just stop at this one. They're like, okay, I factored it. It is factored and it's true, but it's not most factored, okay? Now, what if it's not just x squared and all that stuff? What if I replace it with a sine x or a cosine x? We just finished our trig chapter. These are functions. So I could let a equal sine x and just see what it looks like. 6a squared minus 7a plus 2. This little square, they offer you some notation here. So this is the same as this. So we actually don't have to put brackets around it to put a square. And we do this just to show that the square is not on the x. It just means that you're saying sine x times sine x. All right, well, what multiplies to get 12 and adds to get negative 7? Do you know? And then, and again, I'm going probably at a faster pace than many of you. Some of you might be faster than me, which is great. Feel free to pause when this is happening, right? Pause and finish the problem yourself and see if you get it right. There we go. All right, well, the next one's very similar, so we're not going to do that. Here, however, we have binomials. So I could say let a equal x minus 3. 7a squared minus 4a minus 3. So what multiplies to get negative 21 and adds to get negative 4? You guessed it. Now, a, we stated, was as x minus 3. So let's plug that in. X minus 3, and I'm just going to put a little bracket around that. Just keep it safe. X minus 3. You can see maybe now why I put a bracket around it. A is multiplied by 7. Well, a is x minus 3, so 7 needs to multiply all of a, all of x minus 3. Here, there's nothing multiplying x minus 3 by anything, right? We're not multiplying it by anything, so we can just simplify that. We'd say x minus 4. The other thing we have here is we say 7 times this, so now we have to say 7x minus 21 plus 3, and then x minus 4, 7x minus 18. Sometimes, and I think that might be the case in the next one, maybe we'll do that just to see how it looks. All right, so we have, let's say, x equals a plus 4. Doesn't matter what you replace it with, but if I have a, I'm not going to replace it with an a, right? So let's say 9x squared plus x minus 10, and this is another decomposition problem, so negative 90 and plus 1, so I'm going to say 9x squared plus 10x minus 9x minus 10, so I have x, 9x plus 10, minus 1, 9x plus 10, x minus 1, 9x plus 10, and then we have to replace that back, we have to put that back in with a plus 4. So a plus 4 minus 1. I'm not going to put the little brackets because x is not being multiplied by anything. So we'll have something there. Here I am, plus 4, so let's do that. So I have a plus 3, and over here I have 9a plus 36 plus 10, and oh, we don't get the result I was expecting. Maybe they'd give us an example like this. You might have some in your assignment where you get a result like this, and you might be able to factor something out of that, right? So continue factoring. But 9 or 3 doesn't go into 46, so we're off the hook. Okay?